Science Superstars, it's Jono here from Seneca, and today I'm going to be talking you through the wonderful world of ionic bonding for your chemistry A-level exam. So there's going to be positive points, there are going to be negative points, but altogether it's going to come together to produce something nice and neutral. That was an extended metaphor. Hopefully it will make sense by the end of this episode. Let's dive in. Now, ionic bonding is a type of bonding between oppositely charged ions. It is the electrostatic attraction between ions of opposite charge. Okay? They are very strong and they're much stronger than any type of intermolecular force. But they are generally weaker than covalent bonds, but there are exceptions to every rule. Now, we need to talk about noble gas configurations. Ions form to make noble gas configurations. So an atom will lose or gain electrons until it has the same electron configuration as a noble gas. And what is special about noble gases? They have a full outer shell of electrons. So if we take an example of sodium, sodium's in group 1, so it has a 1 electron in its outer shell. It's going to lose 1 electron to get a full outer shell, because the second shell has 8 electrons in, it's full. So that's what we mean by noble gas configuration. And the periodic table can help us out here, because we can just look at what group an atom is in to determine how many electrons it will lose. So everything in group 1 will lose 1 electron to form a full outer shell, like the sodium example we just talked about. Everything in group 2 will lose 2 electrons, and everything in group 3 will lose 3 electrons. I wonder what happens with group 4, I wonder. Well, you should be able to spot the trend by now. But if we want to talk about negative ions, group 6 atoms will gain 2 electrons to form a full outer shell, and group 7 atoms like fluorine or something like that will gain 1 electron to form a full outer shell. So when we're forming ions, it's all about that full outer shell. They're called noble gases for a reason, honey. They're noble, they're majestic, it's what everyone wants to be, okay? So, which of the following are true about ions? Do they have covalent attractions? I hope you've been listening. They have electrostatic attractions, not covalent. Do they want to react with noble gases? No, they don't. They want to have a noble gas configuration. And remember, ionic bonds are strong. They're stronger than intermolecular forces, but they're not as strong as most covalent bonds. Next, we need to talk about compound ions. Now, we've got a list coming your way. I love a list, but they're not always the most fun thing to listen to. But there are some really important ions you need to know for your exam. We're going to start off with a carbonate, that's CO3 2-. We're then going to go down to nitrate, NO3-, hydroxide, OH-, sulfate, SO4 2-, and ammonium, NH4+. Those are the ones you need to know for your exam. It's only 5, it's not that bad, you'll be fine. Okay, so next we're going to talk about ionic formulae, and basically to determine the formula we balance the charge. And the principle of electroneutrality states that the overall charge must be 0. Does that metaphor from the start make sense now? If you add or subtract cations, which are the positive ions, or anions, negative ions, to find a neutral formula. So let's go through an example. If we take something like calcium carbonate, so if you remember, carbonate ions are CO3 2-, and calcium is in group 2, so it's going to form 2+ ions, it loses 2 electrons. So the formula for calcium carbonate would be CaCO3, because the 2- and the 2+ cancel out, and we get a nice electroneutral compound ion. So that's why electroneutrality is so important and really useful. It will help you determine the formula of an ion. Like in your exam, they could be like really mean and give you some whack ion you've never heard of, and then you've got to be like, oh my gosh, what do I do? You rely on that principle of electroneutrality to determine the formula of that compound ion. It makes everything easier and better. So, do you remember the formula of the sulfate ion? It was SO4 2-. Now, because ionic bonding is so important, I'm going to be really nice and talk through it one more time to make sure it sticks, and just go through the process of how those ions form. So initially, the atoms are neutrally charged. One is going to have a preference to lose electrons, and one is going to have a preference to gain electrons. They use each other and exchange an electron. This forms a positive ion and a negative ion and an electrostatic attraction between them. And that is the ionic bond. So if we take sodium and chlorine, sodium has that one electron it wants to get rid of. It's going to give it to chlorine, which wants to receive one electron. And then boom, that's ionic bond. So that ionic bond is formed by that transfer of electrons. Now, next we move on to talk about giant ionic lattices. Ionic compounds have what is called a giant ionic lattice structure, which sounds really opulent. This means that the structure is made of repeating units of identical structure, and different compounds have different lattices. So sodium chloride has a nice little shaped lattice. So that's one good example to know. NaCl, that's table salt, sprinkle, delicious. And ionic compounds, they have specific properties. So they dissolve in water, and that's because water is polar. They conduct electricity when they are molten or dissolved, because those ions are free to move around and conduct that charge. And they have very high melting points because ionic bonds are really strong. Like, have you ever seen salt melt when you put it in a pan? Nah, it might dissolve, but that is not going to melt. Don't try that though, bad idea. So when do ionic compounds conduct electricity? Do you remember? There are two important circumstances. It's when they're in solution and when they are molten. Three important properties of ionic compounds to remember for your exam. Boom, they dissolve in water. Oh, what else? They have some high melting points. And finally, they conduct electricity when in solution and when molten. And remember that structure, they form giant ionic lattices. So that brings us to the end of this episode of talking about ionic bonding. I hope it was useful. We're going to be covering other types of bonding in the subsequent episodes, so covalent bonding and all that fun, jazzy stuff. So make sure you check them out to get fully up to speed. And well done for being proactive and listening to chemistry revision in your free time. Really good. And I look forward to joining you on the next episode. Thanks for listening.